So, hello everyone. So, as we all know, this is Friendship Day. So, this is Friendship Day special video, and I'm with my best friend Rishabh Jain. So, he has a channel, Coding is my cardio. So, let me first ask Rishabh to introduce himself. So, please, Rishabh, carry on.
My name is Rishabh Jain, and my channel name is Coding is my cardio.
Okay.
That's all.
So today we are going to discuss problem. The name of the problem is trapping rainwater problem, and it's a very famous problem. It's majorly asked in most of the companies like Google, Amazon, and all of the companies. It's a very famous problem. Okay. So without wasting our time, let's move toward the problem section. Okay. So let me show you the problem first. So this is the problem. Like you have given an array. Okay. Okay, so thanks, Rishabh. So you have given an array of non-negative integers representing height of blocks. Like this is representing you have given a size of array and some elements, all the elements of array representing you the size of the the height of the blocks. Okay, like height of the building and something. I'll tell you what is the height of building or what is height of blocks means at index I as ai. Okay, where the width of each block is 1. Compute how much water can be trapped in between blocks after raining. Okay, so structure is like below. We can trap two. Okay, so like I'll explain you the whole things. Firstly, we just read the problem. Input, this is the input constraint. We have to just number of cases. Okay, so constraints were very high, like 10 raised to power 7, so we have to make we have to go with on. So okay, so as I told you, like this is the size of the array. This is 8 is the size of the array, and these all are the array elements. Okay, and particular array element is representing the height of the building. Okay, so let us assume कि like this is the rainfall, like बारिश हो रही है ना, बारिश हो रही है एंड दो बिल्डिंग्स के बीच में हमें कैलकुलेट करना है कि लाइक हम कितना वाटर स्टोर कर सकते हैं, लाइक कितना पानी स्टोर कर सकते हैं. ओके, सो लाइक ये बारिश हो रही है, तो जब बारिश होगी तो इसकी हाइट कितनी है, लाइक 7 इज द हाइट ऑफ दिस पर्टिकुलर बिल्डिंग एंड the left and the what is the height of the another building is 8. Okay, so at that particular sixth building how much amount of water we can trap, like हम कितना पानी स्टोर कर सकते हैं. This is 1 unit. Why 1 unit? Because this is the only part, है ना. और अगर हम इससे ज्यादा फ्लो, अगर हम ज्यादा भरने की कोशिश करते हैं तो वो लेफ्ट से ओवरफ्लो हो जाएगा, मतलब पानी बाहर बह जाएगा. like this I'll tell you, like this कि पानी यहाँ से बह जाएगा. ओके, सो हमें सिर्फ उतना ही पानी भरना है जितना बिल्डिंग का साइज हो, लाइक मिनिमम साइज ऑफ द बिल्डिंग. ओके, सो लेट मूव टू वी कांट फिल वाटर एट 7 बिकॉज देयर इज नॉट एनी बिल्डिंग, बट वी कैन फिल द वाटर एट द सिक्स बिल्डिंग, लाइक ओके, बिकॉज ही हैड अ लेफ्ट बिल्डिंग एंड ही हैड अ राइट बिल्डिंग. ओके, सो हम कितना फोर्थ पे कितना पानी स्टोर कर सकते हैं, दिस हाइट ऑफ वाटर. ओके, सो अगर हम इससे ऊपर भरते हैं तो कितना, लाइक लेफ्ट मोस्ट तो इसका 10 है, लो सॉरी नॉट द लेफ्ट मोस्ट, द लेफ्ट एलिमेंट जो है वो उसका 10 है, बट जो राइट है वो कितना है, वो 8 है. सो हम उससे ज्यादा नहीं भर सकते बिकॉज अगर उससे ज्यादा भरने की कोशिश करेंगे तो वो फिर से बाहर बह जाएगा. ओके, और जब आगे एलिमेंट की बात करते हैं विद, तो यही सेम सिनेरियो सबके साथ होगा. लाइक यहाँ पे मिनिमम लाइक मैक्सिमम हाइट है राइट बिल्डिंग की 10, तो मैं 10 यूनिट तक राइट तक चला सकता हूँ, बट मुझे अपना देखना पड़ेगा कि कहीं से बाहर पानी ना बह जाए, लाइक ओवरफ्लो की कंडीशन ना आए. सो फॉर दिस पर्टिकुलर कंडीशन वी हैव टू फाइंड द minimum height of building, like we have to find the building which had a minimum height. Okay, so now here the minimum height of a particular building is 6, so we can fill that much amount of water. Lekin but we have to calculate the amount of water. This is the size of the building, but we have to calculate how much amount of water. So what will be the amount of water, like this is the height of building, like 2 is the 2, like at a building at a 2 floors. Okay, so like 2 is the height of the building. Okay, and we can fill the water till 6. ऐसी कोई बिल्डिंग है जिसका हाइट 6 तक है, मैं उस तक स्टोर कर सकता हूँ, तो कितना कर सकता हूँ, 6 minus 2, तो दैट इज 4 यूनिट ऑफ वाटर. ओके,
Above the building.
या above the building 4 unit of water. In case of 3, what will be the amount of water? We have to subtract the size of that particular building, like total water 6 minus 3, so how much amount of water, this is 3. Okay, and in case of 4, in case of 4, how much amount of water we can store, this is size of building is 4 and total amount of water we can store it 8, so 8 minus 4. Okay, and same is with the 6, the left building had a size 7, this is the only amount of water we can store. So what will be the quantity of water we can store, only 1 unit of water. Okay, so from here we can conclude that like we have to find the minimum building, like the left with the maximum height, right with the maximum height, and we can fill the water in between that, like about the minimum height, like हम उतना ही वाटर भर सकते हैं जितना उसमें मिनिमम आएगा, मतलब मिनिमम हाइट की जो बिल्डिंग होगी उसी के अकॉर्डिंग हम पानी फिल कर सकते हैं. सो ये चीज तो यहाँ से क्लियर हो गई. ओके, so without like let me tell you the first the like the naive approach, then we'll move toward the efficient approach. Okay, so what will be the naive approach? We'll simply check the array element, we don't fill the water at 7 because it doesn't have the left
Support.
element, so it doesn't have any kind of support, like
The left side.
yeah, at the left side. So we can't store any amount of water at 7, but we can store the water at 6. So what will be the minimum, like what will be the support of it to its
Left
so the
side.
left support is 7, has a height of 7, and the right support has a size
8.
of 8. Okay, so हमें क्या करना है कि एक loop run करनी है. We simply have to run a loop for a particular array element. For that we have to find the minimum like left building, and for that particular we have to like the maximum height with the left part and the maximum height with the right part. Okay, so for us for 6 we run a loop and we find 7 is the only building which had a maximum height, and in case of 6 to its right we have the building which had 8 is the height, like sorry, 10 is the height, 10 is the maximum height, but we can store only up to only the amount of water is 7. So this is the minimum height, so we have to find the minimum height and then we have to subtract that particular building height. Okay, so 6 is the height of that particular building, so we have to subtract 7 minus 6. What will be the unit of water? This is 1, and we have to follow each this simple step with every element. Okay, so now Rishabh will tell you the naive approach and the efficient approach too. Okay, so from here I'll ask Rishabh to continue. So Rishabh, so you can continue from it.
Okay, so let's discuss the naive approach now. First of all, we'll take the input of the test cases. Now the size of the array. So now we'll iterate through the array using this loop. Yeah, so this loop will be iterating our whole array or our whole input array, and from index I equals to 0 to I less than n. And for every index, we have to check that is there any left or right support. For example, for index 0, we'll check that is there any left support for index 0 element. So no, there is no support for the left support, and for this element there's we'll run a loop to check the right support also. So this work will be done for every element. So let's make some variables. Lmax and Rmax. Now we are checking if there is any element on the left side of the index I which is greater than or which is the highest. Let's say which is the highest. Maximum on the left side. We'll start from I minus 1 and go till I get equals to 0 and j minus minus. We'll check okay. So this is the technique we use to find maximum in an array. So we are not our task is not to find the maximum in the whole array. Our task is to find maximum element from j I minus 1 to I equals to 0. The left side of the index I.
Because we don't have to consider that element, like at which we are right now.
Yeah. So therefore we have taken j equals to I minus 1 here.
Yeah.
So that will be considered as Lmax, and maximum element on the right of the index I will be considered as
right
Rmax.
Yeah.
I plus 1 to I less than n. Okay, so these things are done. Now what you have to do is that, for example, if we are iterating on the outer loop, and on the iteration where the value of I is 1, that is on this element, so what will be the Lmax? Lmax will be 7 and Rmax will be 10. So we'll do what is going to be the answer: minimum of Lmax and Rmax, that is minimum of 7 and 10, that is 7, and the answer will be 7 minus 6.
Yeah, height of building.
Yeah, minus height of building. Yeah, so now our code is complete. But this approach, what is the time complexity? What will be the time complexity of this approach? It will be big of n square.
Yeah, so this will not be considered for the summation.
Yeah, actually it will be theta of n square, because for every element we are definitely iterating to for every element we are definitely iterating the whole array. So the time complexity will be n cross n, so n square, and that's not gonna work because the time constraints are very high. They are 10 to the power 7. The size could be 10 to the power 7. So 10 to the power 7 into 10 to the power 7, 10 to the power 14 will not work.
Yeah.
It will give us the TLE. So let's make it more efficient. So you can pause this video now and think of an efficient approach to solve this problem.
Yeah. And if you didn't find anything, or didn't be able to, do not be able to solve that, not be able to find the efficient approach, then come here and you can see the video.
Okay, so let's discuss the efficient approach now.
So for that efficient approach, firstly you have to be you have an idea about a leader in an array problem. Okay, so you must be aware of, like जब तो आपको पता होना चाहिए what is leader in an array problem. So you must be friendly with that particular problem. Okay, because without that problem you are not going to get the idea. Okay, so I'll given the explanation in the previous video of leader in an array, so you can go firstly go there and see the video.
Yeah, then come here and check the solution. Okay, so let's develop or discuss some logic that how to make it efficient. So for every element, we are wasting time in checking Lmax and Rmax for every element in the array. So what rather than that, what we can do is we can make use of an auxiliary space and store Lmax and Rmax up to that point. For example, up to index 3, the maximum is 8. Yeah, it is very much evident that the value at index 0 is 7 and 6, 8 and 4. And what's the maximum out of all these? It is 8. So likewise, as we do in leaders in an array problem, that we take minimum from the right side, right? So similar to that, we'll take we take maximum in a leader array problem from the right. So similar to that, we'll take maximum from the left, both from the left and both also from the right.
Right, yeah.
Why from the right? Because
we also have to find the right max and we have to find the left
L
max. So that's why we are making two arrays, like one for the left storing left elements and left max element, and one for the right max element.
So if we want R max, then we'll go from right.
Yeah.
And if we want L max, then we'll go from left.
Left.
So let's dive into the code. So we need an extra auxiliary space. So we'll make an array Lmax. You may have noticed that Lmax was our variable in the previous naive approach, but now it has become an array. And also Rmax. So how it is similar to leaders in an array problem? Leaders in an array problem. In leaders in an array problem, we were having only Rmax.
Yeah.
Right. We were calculating maximum from the right side.
Yeah.
But in this problem, we are having both Lmax and Rmax. So we initialize these arrays as we do in leaders in an array problem. The first element in the Lmax array would be the first element of the array itself, and the last element in the Rmax array would be the last element of the original array, its input array itself.
Yeah, so it will be the last element.
Yeah. Lmax I equals to maximum of Lmax I minus 1 comma Lmax I. Similarly, for Rmax, we'll go from I equals to n minus 2 to I greater than equals to 0, doing I minus minus, and Rmax would be maximum of Rmax of I plus 1 and Rmax of I. So in the line 13 and line number 14, we initialize both the Lmax and Rmax array. Now the work is pretty much similar and same to the previous naive approach. What we do is we do answer plus equals to minimum of Lmax up to that index and Rmax up to that index minus array of I, the height of the current building. Let's also make
the answer equal to.
So this is the final code.
Yeah, so it's now it's giving correct answer. I hope you all get the logic, and if you find any difficulty or you have any problem in the code, then you can ask in the comment section if you have any query regarding the problem.
Until now we have discussed two possible solutions, one naive solution and second is optimized solution, big of n solution, um, and the time complexity of the efficient solution is also big of n.
Yeah,
time complexity and space complexity both are big of n, as it is requiring an auxiliary space.
Yeah,
we are making an extra array. Third solution.
So the third solution must be like 2-pointer solution.
नहीं stack वाला.
Okay, so the third solution is using stack. Okay.
So before watching this video further, watch our previous video on stock span problem. The link of both the leaders in an array problem and stock span problem are in the description. You can check that out. So let's move to the third possible solution. Third solution will be stack based.
Using stack.
And fourth solution will be a two pointer solution.
Okay.
So let's discuss third solution. So you can see here, moving from left to right, when we see a downfall in the height, for example, from 7 to 6, we see a downfall in the height.
Downfall in the height of the building. Okay.
And from 6 to 8, we see a uplift.
Yeah.
In the heights.
There's an increase.
So we like this, we get to know that there is a building in between that in above that the water can be stored, right? So how we can apply stack concept here? It is pretty much similar to stock span problem. So what we do in stock span problem, that we see that how many elements on the left are smaller than the current element, right? So similarly, we'll push elements if they are smaller than the top of the element of the stack. So in the stock span problem, we also do the same. We push elements into the stack until they are smaller than the top of the stack.
Yeah.
And we pop out elements when we find we find an element that is greater than the top of the element on the stack. So the logic, the algo goes like this. This is while iterating through the array for every element. If array of I is greater than stack dot top, first of all, let's see if array of I is less than s dot top. Okay, so what we'll do, we'll push that element. So for example, first of all, we'll push the first element, that is 7, into the stack. Okay.
Because if we didn't push anything, then the stack is empty. So we don't have to consider empty stack. So that's why we are putting 7 into the stack.
Next element will be iterating through I equals to 1 to I less than n. So our first element to iterate will be element at index 1. So we now 6 comes and we check that whether 6 is less than the element on this top of the stack. Yeah, 6 is less than 7. So what we do, we push 6 into the stack. So we pushed 6 into the stack. Now we move to, as we are iterating through the array, we now move to next element, that is 8. Now you may have already guessed that what we are gonna do when now 8 is greater than the top of the element on this stack. So we'll go not follow this line of code. We'll go on the else part. So what to do when an element is greater than the top of the value at the stack? We what does this represent? This represents that we have found an uplift in the height. So as we have found an uplift in the height, then we are sure that there definitely will be a building of height lesser than the current element 8. There definitely will be a building lesser than the building of the current height. Yeah, so 6 and 7 are less than 8. So before adding 8, we'll pop 6 and 7. So 6 is popped, 7 is also popped. We'll push 8. Now move into next element, that is 4. 4 is less than 8, so we'll push it into the stack. Now next element, that is 10. 10 is greater than 4. 10 is greater than the top of the stack, that is 4. So we'll start popping elements from the stack. So we'll pop 4 as 4 is less than 10. Also 8. Also it is also less than 10. Now the popping is done. So now we'll push 10 into the stack. Now you got that idea. Now we'll push 1 and so on. But you may be thinking that I have not told you how to compute the answers, right? We are just iterating through the array and making operation into the stack. Yeah, so for that, let's dive into the code, initializing the variable answer to 0. Now, uh, as we know that in both the conditions, when the element is less than or greater than the top of the stack, in both the condition, we are going to push that element into the stack, as you can see in this code also and this part also. So we are not going to write it in differently. We are just going to make condition of this when array of I is greater than stack. And one more thing, that we are not going to push the elements into the stack, we are going to push the indexes into the stack, right? For example, instead of 7, we'll push its index, that is 0, like so. So if array of I is greater than, you can say s dot top, as we are pushing indexes, so we'll do array of s dot top. Then what we do, if we find an element, we are iterating through array, and the element we are iterating through is greater than the top of the stack, what we do, we start to pop elements, yes, from the stack. Yes. So while we pop until the stack is completely empty, so s dot empty is equals to false. Yeah. Yes, if it will be true when stack is empty, so it should be false. That means the stack is currently not empty, that is it has some values. Then only I'll run this loop when the stack is not empty. Yes, it is having some values, then only I'll be able to pop from it, right? And also the array of I, the current element should remain greater than the value at the top of the stack, right? Yes. Why am I writing this? Yeah, you may have guessed right. As we can see, while uh, computing for traversing through the array, and in the iteration for 10, we saw that 4 was also less than 10 and 8 was also less than 10. So we are running a loop, and yeah, it goes like this. We have to check in every iteration that it should be greater than the top of the stack. So now we'll store the top of the stack element at the top of the stack before popping into a variable named last. Yeah, you can name it anything, but yeah. Okay. I'll tell you why we are making these variables. So bear with me for a few minutes. Yes. And we'll do answer plus equals to, yes, yeah. So now I'll explain that why I have made these variables and what's the use of them. So I have made a variable distance and a variable multi. So to understand the use of these variables, let's take some use cases and examples. So from index 4 to 7, let's see what happens if I solve this. So first of all, I push 10 into the stack. Now next element 1 comes. Now 1 is less than 10. So I again push it into the stack. Now 2 comes. 2 is greater than 1. Yeah, 2 is greater than the top of the stack. That is 1. Now what I do, let's see from the code. I start to pop elements from the stack on this condition, right? So only one will be popped out because uh, while iterating from the inner loop, one only is less than 2 and 10 becomes greater than 2. So that condition, while condition will be false and it will break. Okay.
Yes.
So let's see what other variables have to do. Last, distance, and multi. So last, in the variable last, we'll store 1, right? Before popping it, we'll store 1 into the variable last. Let's now talk about distance. What this variable has to do. So we was seeing this example. In this, we have popped 1 out of the stack and 2 is our current index. That is I here. We are iterating for this element 2, right? So our I is in the index of 2 and s dot top is the index of 10.
Yes.
Right, because we have already popped 1 out of the stack and now our uh, top of the element on the stack is 10. Okay, so 6 minus 4 minus 1, that is the distance between these two elements. So what does it represent? It represents that how many buildings are there between the element 2 and 10, right? So 6 minus 4 minus 1 gives us 1. So there is only one building between 2 and 10. That is evident. We generally use this formula a lot.
Yes.
Right. So now our next variable is multi. It is very important rather. Multi, what does multi stores? Okay, so you may have guessed this fact that after popping out all the elements that are less than the current element,
Okay.
we are left with the element greater than the current element.
Yes.
Right. For example, our current element was 2.
Yeah.
And we were checking for all the elements less than 2.
Yes.
And we were popping them out of the
Yep.
stack.
Yeah.
So we popped 1 out of the stack and now we are left with an element greater than 2. So that is very clear that the elements which are popped out, for example 1 is popped out, so 1 will be less than both 10 and 2, right?
Yeah.
Okay, so 1 will be less than both 2 and 10, right? So it will be between both large buildings. So it is very clear that we can store water above this building which is popped out recently. So that's why we are keeping uh, the top and storing it in a temporary variable last. Right, now I hope you understood why we were doing that. Yeah, so that we can compute it, right? So we are taking similar to the approaches we have discussed before in this video. What we were doing there was we were taking minimum of L max and R max. So what they basically are here, they are basically L max is array of s dot top and R max is array I. Why? Because R max will be the current index because it is greater than the popped out in element, right? That's why we are popping it out, right?
Yes.
Because it is less than the
Yes.
current element. So it is less than the current element, and it is also before the current element.
Yeah.
So the Rmax of the popped element is the current element, that
Okay.
is 2.
Okay.
And Lmax of the current element is what is left on the stack, on the top of the stack, after popping out all the elements
Which are smaller than that particular element. Yeah.
which are smaller than 2,
Yeah.
the current element.
Yes.
So now I hope that it is clear that why we are taking this, and it is evident that what we did in the previous approaches was that minimum of Lmax and Rmax minus current
Yes.
element, right?
Yes.
So current element is not what you are, what I am saying current element is here. Current element is actually array last, right?
So basically, we are subtracting the size of that building to,
Yeah.
like in the
The
form of array
smallest
last.
building, the popped out building,
Yeah.
is the current element of the previous approaches.
Yes.
Right.
Yes. Yes. You are right.
Okay. So I hope that it is pretty much clear, and now it is very evident, right? We do answer plus equals to distance into multiply. I am also explaining this also because it is also a bit tricky. So let's see. There is a 1 unit space above the building with height 1, which can be filled with water, right? So I'm going to fill it according to the formula we have derived, that is minimum of array s dot top and array I. Minimum of s dot top is array s dot top is 10,
Yeah.
and array I is 2, right? So minimum of 10 and 2 is 2. So 2 minus array last, what is array last?
Which is
1, right? 2 minus 1 is 1. So that is nothing basically, but basically 2 minus 1, right?
Yeah.
That the similar thing that we were discussing in the previous approaches.
Yes.
Right? So it is very evident. And now, why we are multiplying this answer with distance? What's the use of it? Why we have already computed this in the previous approaches. We were doing like answer plus equals to directly adding this thing into the answer, right? But why we are multiplying something to this thing in this approach? Now let me tell you that. Why? Because there may be more than one elements which are popped out consecutively. For example, if we take this,
Okay.
so in this example, when we arrive at 8, then all the elements will start popping, all the elements 5, 2, 3, 2, right? Because all of them are smaller than 8, right?
Yes.
So there may be more than one elements which are smaller than the current element. That's why we are taking distance variable, right? Okay. So let's dry run or understand it further. Okay. So after computing the answer of the current element 2, we'll push the current element into the stack. So I'm sorry about that also. I forgot that also. So I have to do as dot push, right? Whether it is greater than or any other case, it is less than or equals to. In all the cases, I'll push that element in the stack. Okay, so I'll push 2 into the stack.
Okay.
For why? Because for further computation, because there um, can be possible, and it is possible, that some water is going to be stored above 2 also. So it also needs to be popped out by a bigger value than 2, right? 3 is going to pop 2 out of the stack, and that is going to give us the answer which is going to be stored above 2. So the work of 2 is complete now. So now let's move to the next element, 3. So now we see that 3 is greater than the top of the stack, 3 is greater than 2. So we do the same. We start to pop out elements from the stack which are less than 3. So we first pop out 2, right? And for 2, we calculate these following things. Last equals to s dot top. S dot top is the index of element 2, that is 6. We store it in this temporary variable last, and then we finally pop out 2, right? Then we pop out 2 out of the stack, and next we calculate distance. Now this is important. Now you will understand it more better. So now a distance is I minus s dot top. What is s dot top? What is on the top of the stack? It is 10. Index of 10 is s dot top is basically the index only. So s dot top is 4 and I is 7. So 7 minus 4 minus 1 is the distance. So 7 minus 4 minus 1, what does it gives us? It gives us 2. So right, it is evident that there are 2 buildings between 3 and 10. So until now, before we were computing the answer for 2, we have calculated the answer of this answer, 1 unit of water. Now it remains for us to calculate the answer of these 2 blocks, right? So this answer is calculated by 3 only. That's why the distance is 2, right? That's why the distance is 2, because we have to level until 3. We have to reach why 3 is computing, why on the chance of 3, why on the iteration of 3 we are computing this answer, because it will level up until 3. Yeah, it will level up until 3. So this will give the complete answer packed until 3. Now moving further, what we now next comes 6 in front of us. So and obviously we'll push 3 before moving to next element.
Yes.
Yeah. So now comes 6. So 6 is greater than 3. So we'll firstly we'll store the index of 3 in a temporary variable called last. So last equals to 7. So and moving next, 10 is not greater than 6, so will not pop it out. So now distance would be I minus s dot top minus 1. So 7 minus 4 minus 1, what does it gives us? It is 8. So now moving to distance, that is I minus s dot top minus 1, and what the distance would be? I minus 8 minus 4 minus 1. Yes, that is 3. So it is evident there are 3 blocks between 6 and 10. So now your observation will be more clear that before the element 6, that is up till 3, the answer is completed. Yeah, we have made this blue line to show that the water is filled up till the height of 3, right? Because the answer of 3 was computed in the previous iteration. So the water answer is also computed totally, right?
So the total number of water, like the quantity of water, how much amount of water is going
Up
to
till
be stored?
the height 3, it is calculated.
Yes.
Now it remains to calculate the answer up till the height 6, right? So therefore we calculate distance equals to 3, and uh, 6 minus 3, minimum of 10 and 6 is 6, and 6 minus the height of the previous building, yes, 6 minus 3 is 3. So we do 3 into distance. What was the distance? It was also 3. 3 into 3, 9. So it is also evident we'll store 9 unit water above this building like this.
Yes, 3 on that, 3 on that,
Okay.
3 on that.
So that was the last element of the array, and so was our last effort on this solution number 3. Here we complete it. Yeah, so this is the final code. We have to push the index of the first element, that is always 0, into the stack in the starting. And one more thing, that if the stack is empty, then we are not going to compute anything after that, right? So this is the final code. Let's try and submit it.
Okay. So now let's we discuss the fourth approach, that is two pointer approach. So what is, let me explain you first what is two pointer approach. In two pointer approach, what we have to do, we start iterating the array from both sides, like from left and from right. Like in this particular condition, we have 7 at the is the leftmost element and 6 is the rightmost element. So we'll traverse that particular array from left. We'll make a pointer for left, like this one is for L is representing the left pointer and R is representing the right pointer. So L is for left. Okay, what we search for, we check the element, we check the particular element. So now we had an element, the left element is 7 and the right element is 6. So we check if the element, if which of the element is smaller, like the left element or the right element. If left element is smaller, then we fix the right element, and iterate, start increasing the pointer by from left. Okay, if right is greater, then if right is smaller, then we start iterating from right. Why? Because it is the maximum support we have, in this particular case, 7 is the left support and 6 is the right support. So 7 is the support which can support water at max, but the water will spill out from the 6. So we have to search for the element, if there is any element at right which is greater than 6, so it can hold the water. Okay, so our pointer is at 7, so we change our pointer. Which one pointer? The pointer is from right, so we shift the pointer to the next element. Okay, so now we'll store that particular value, like we store 6 in any variable, or 7 is also in a variable. We check if the element is smaller or greater. If element is smaller, then what we do, we simply subtract the height of that. We find the minimum, as we are finding like minimum of max L comma that particular, minimum, not maximum, minimum of max L comma a particular element, and then we subtract the height. So here minimum is 3, because we have maximum currently 6 and the next element is 3. So max minus, so min is 3, so min minus particular height is 3. So how much amount of water we can store here? This is 3, like only this amount. So this is the amount of water we can fill here. Okay, so again, again we search for the next element. Our currently max is 6, current max is 6, L max is 6, and R max is 6 and the L max is 7. We'll search for the element. If the element is again the element is less than 3 is also less than, like we have the maximum is 6 currently right now, so 6 is also less than 7. So we change the pointer, increases the pointer by 1 from R, from means left, from right. Okay, so now it is at 2. So okay, so at 2, how much amount of water we can store? We'll check it by maximum, or from, like we find the minimum of current comma max of L is 6 and current is 2. So 6, minimum of 6 comma 2 is 2. So we subtract that particular height. So 6 like minus 2. 6 minus 2, not 4, sorry, minimum is 2. Yeah, 6 minus 2. Okay, So now
4.
how much amount of water we can store here? 4.
Above the 6
Yeah.
2-unit building.
Above the 2-unit building. So this is the amount of water we can store. Now again we'll
So let's jump into the code, and meanwhile you can explain further,
okay.
because it has been quite theory lecture so far. So let's do it some practical things.
Okay.
So I'm erasing the code, doing it in a fresh start. So I'm going to explain the code a little bit, how many variables we are going to require. So first of all, as we explained, we are going to require 2 pointers, that is L and R, using here, and L is the left initialized from the leftmost, and R is the rightmost pointer.
Yes.
Okay. And 2 variables are also required, max L and max R. Right. And obviously the answer in which we are going to store our final answer. So as we know, in most of the 2 pointer problem, in what we do commonly is we run a loop and we put a condition where we end this loop when the left pointer exceeds the right pointer, right? When both the pointers crosses each other. Right. So this is a very common thing we do in most of the 2 pointer problems, right? And uh, what we are going to do inside the loop is we are going to check that, first of all, as we explained, that first of all we're going to check that whether uh, L array of L is greater or array of R is greater, right? So if array of L is greater than array of R, then what we'll do, then in this case we are sure that we are having a pretty much good amount of support from the left side, because array of L is greater than array of R. Array of R is small, so we are sure that water is not going to spill from the left side. Water is there is a very much chance that water is going to be spilled out from the right side, because array of R is smaller. As we can see here in our example, 6 is smaller than 7, so there's a much probability that water filled anywhere in between the buildings is going to be spilled from here, right? So in this case, what we do, if array of R is smaller, we compute from the right side, right? We do R minus minus in the pointer, because we are sure that we are left we are having a fixed value and it is going to support us, right? So we are going to do R minus minus, and in else condition, when array of L will be less and array of R will be greater, then we are sure that on the right side we have pretty much support, then, and from the left side we'll carry on our calculation, so therefore L plus plus. Yes. Okay, now let's move on to the calculation part.
Yes.
Like
We have to calculate now the answer. What will be the answer?
Right. So in this case, we are going to iterate through whole of the array, and the time complexity will be big of n. Right. By doing the iteration for every element, we are going to compute that how much water is going to be stored above that building. It's very simple thing. So what we are going to do is, as Gaurav has told, that if array of R is less than R max, basically, then what we do, for example, here 3 is less than R max is 6. So we are sure that if the next building to that is lesser than the current building, so we can store water above it, obviously, because it is smaller than the right building.
Yes.
Right. So we are going to compute our answer for this particular iteration. So what is the answer? What the answer will be? Answer will be simply R max minus current height of the building.
Yes.
That is area of R. Okay. And in the else part, when the next building is actually greater than the previous building. For example, instead of 3, we had, let's take 7. So in that case, what we would have done, we would have updated the value of R max, right? Uh, in that case, we could not have calculated answer for that iteration because no amount of water can be stored in above that building in that case, because water will be going to spill from the right side. So we cannot store water above this building. Why? Because it is greater than the right support, right? So water is going to spill out from here. So we cannot compute answer in this case. And in this case, what we have to do is we have to update the value of R max.
So now our R mix changes to
Current
7,
element.
current element.
That is array of 5. Now this is complete. And similar thing we'll do in the case when the left support is smaller than the right support. Right? So for example, let's assume that left support is less than the right support. Yeah. For example, in this case, we are going to start from left pointer will be initialized at the index 0, at the value of index 0. Right pointer will be at n minus 1 index. So in this case, array of L is less than array of R, evidently, because 5 is less than 6. So in this case, we are sure that right pointer is going to support us, but there's a condition that water can be spilled from the left support. So we are going to start computing from the left side.
Yes.
You can understand, we can understand it like this, that in the previous approaches, what we generally did, we did minimum of L max and R max minus current height of current element. So we basically computed minimum of L max and R max. We focused on minimum of L max and R max. So here also we are focusing upon the minimum side, which is the left side, and we are going to starting to compute our answer from the left side only.
Yeah, we are start moving our pointer from that particular side where we found the minimum
of maxes. So it's pretty much the same. If array of L is less than L max, then what we do? We compute the answer.
Yes.
Because it is shorter than the left support.
Yes.
So we can, it is obviously short. If it is shorter than the left support and left support is also shorter than the right support, then the current building is smaller from both left and right.
Yes.
Right?
Yes.
So what we do generally is minimum of L max and R max. So minimum of L max is actually L max only. Minimum is actually L max only. So simply we do as we did on in line number 20, I guess. Yeah. Answer plus equals to
Maximum
L
of
max
L minus particular array element.
right. Else
If the element is greater than, then we changes our max variable.
L max is updated to current element. Let's try and summarize. Okay, so here we are completed with the trapping rainwater problem
Using 4 approaches.
Yeah, 4 approaches are, I think it is clear to you guys, and if you have any doubt, then please let us know in the comment section. We'll try to answer it.
Yes.
And
the link of the problems that we have discussed, like previously you have to solve that particular problem, are provided
leader and array and stock span problem, both the links are in the description, also with the code of all the 4 approaches that we have discussed. So thank you guys.
Thank you everyone.
Please support the channel of Gourav
and Rishabh's too. My channel name is Code with Gourav, and Rishabh's channel name is Coding is My Cardio. So the link of the Rishabh channel is also in the description. So please also subscribe Rishabh channel too. Thank you all.
So in future we are going to do some other exciting stuffs also. Like collaboration and solving other exploring other technology stacks like Android development and web development. And for future videos, we are planning to have infographic infographical explanation.
Yeah.
So let's see
How
when
much
the time
support
comes.
we are getting. It's depend on that thing. Like
Yeah.
so. Thank you
Thank
everyone.
you.
Thank you everyone.